All right. So this one has two questions up here. We've got the side view of an oblique triangle ramp, and we're asked to find one of the sides. And then we're going to find the height of that side to the ground. I believe there's one on the homework worded almost identical to this. Different numbers, but the wording is almost the same. So, what I'm going to do is I'm going to start with drawing a ramp. Ooh, that's not bad. So we're going to have a ramp. And they tell us that it's an oblique triangle. So we're going to just kind of draw ourselves a non-right triangle that looks kind of like this. I'm so good at lines, y'all. It's so pretty. But it gets the point. I'm going to label this one D, label this one E, and I'm going to label this one F. So we're going to take the information we know and fill in what we can't. What we can. So we know that angle D is 42 degrees. We know that angle E is 23 degrees. And we know that side E, remember side E is across from angle E. That's 19 feet. So that's just labeling the things we know. What we're asked to find is side D. Lowercase d means that's the side. So we want to know side D. How could we find side D? How could we set it? I can't hear when people say ideas when you mumble in conversations about other things.
Not for real.
Uh-huh. Yeah, sure. What's up? Yeah. We're going to use the loft sign things from yesterday. So we're going to have D over sine of its angle, sine of 42. And we know that's going to equal, it's going to be in the same ratio as the pair that I know. I know 19, bless you, and sine of 23. So the side over the sine of the angle, they are in the same ratios. So how do we get D by itself here? How do we solve for D? Multiply by sine of 42. So we know that the measure of side D is going to be 19 sine of 42 over sine of 23, which is technically correct. Not super helpful. What is the measurement of D? Use a calculator. Say louder. Yeah. We're going to have 32 point, I'm going to say 5/8 or 5/3/8. What unit? Feet. So we know that this side, oops, that's not the button. My pen is just being a jerk here. This side is 32.538 feet. Do we care what the other side is? No. I mean, you can look it up if you, you can do it if you want to. We have the skills. We'll get there. It's looking at a slightly different thing. It's not, but we're not asking about this side. We don't have to solve the triangle. We don't always have to find all of the pieces. It just asked us what this side was. We didn't have to go that far. Our next question is, what is the height from the ground? So we want to know how tall this ramp is. We want to know its height from the ground. You want to know h. I'm actually going to take this unit back off of here. No, I'm going to leave it. Never mind. We want to know the height off the ground. What the heck can we do here? What? Angle F. If we know this angle, don't we then know this angle? If I'm good at drawing straight lines, because those are supplementary. Right? And if I know this angle, if I know EF, let's just call this H so I can talk about it. If I know EFH, I can use my law of sines on H because I know an angle here. We can still use 90s in our law of sines. That's totally fine. So what is our oblique triangle's angle F? What is this guy? So this angle here is 115. We know that because all of the angles are going to sum up to 180. 42 plus 23 plus 115 is 180. Which means this angle F is what? 65. Because this is, if I was good at drawing, a flat line. They're supplementary. So this angle and this side are related. We know we could find H with the sine of 65. What other angle inside do we know in that little right triangle here? What other ratio in this little tiny triangle do we know? We know our 90 and our 32.538. So our side was side D, 32.538, and our angle is 90. So we can use it even on right triangles out here. This is totally fine. We can still use law of sines on right triangles. It's just kind of a complicated way to do it. So how high is this off the ground? Mm-hmm. 29.489 feet. We could also come in here, since this is, sine of a right angle, we could do, our opposite over hypotenuse to do it that way. Like, that's totally fine thing to do it too. We can still use our right triangle lines and do opposite over hypotenuse. But we can also use the way our brain is currently going to do it this way. Okay, so I wanted to do one like that. That one was on our list for yesterday, but I didn't want us to not do one like that because I'm pretty sure there's one just like that on the homework. Or at least very similar. Okay, so then we're going to look at those story problems that I printed out for you because they're so nice. So that you don't have to like try and speed read a paragraph. So we're going to start with the 2 fire towers, which is actually a real thing, and they really do. And there's people whose job it is in the summer to live in the forest and watch out for fires. I follow one on TikTok. It's fascinating. It's like a tiny house in the woods, but like a mile up. Like it's crazy high. So we've got 2 fire towers lie on an east-west line and are 5 miles apart. Okay, so I'm going to start with that. So I've got an east-west line, and I've got 2 towers. We've got Tower 1 and Tower 2. And I know they are 5 miles apart. This is going to be Tower 1, and this is Tower 2. I'm going to make them T1 and T2. So Tower 1 spots a fire with a bearing of north 27 east. So if we look down at Tower 1 and we're trying to go north 27 east, we got to pull up our old bearing information. So north east, and it's 27. Because I'm going to draw it way farther out, but I was reminding us how to do our bearing. We take it off of the north, and we go east. So it's going to be somewhere up there. This is 27 from our north. Tower 2 sees the fire, and it's north 32 west. So again, it bases itself off of its own tower, and it's north, west, east. And it goes 32 degrees west to get to that fire. What we want to know is the distance between Tower 1 and the fire. So I want to know this labeled D. What in the world do we do? What do we start with? Do we know any angles inside our triangle? Can we find some angles inside our triangle? Yeah. So let's start with that. So let's look at Tower 1's angle. I know it was 27 degrees off of true north. So what is this angle between our like ray here and east? 63. It's a 90 degrees. So it's a complementary, not supplementary. So this is going to be 63 degrees here. How about for Tower 2? 58. Which means our top angle up here, I'm gonna call this F, our fire angle. What is angle F's measurement? 59. We needed to get all the way to the F angle because I need to have at least one ratio that we know. And the only distance I know is between the 2 towers. So I needed this angle so I could use this ratio. because we want to find this distance, which means we're going to use our law of sines, and we're going to set up our ratios. I'm going to use my 59 and my 5 miles, and I'm going to use my 58 and the distance that we want. Since I want to know a side, we put sides on top. So I'm going to have my 5 miles over sine of 59. And we know that ratio is going to be the same as the distance d over sine of 58. So solve this for that distance. Multiply by the sine of 58 on both sides. What is the distance from tower 1 to the fire? Yeah. 4.95, 4.947, depending on how we round it. I'm going to put 47. I feel like I'm in 3 decimal places. And it's miles. Again, I didn't get asked the distance from tower 2 to the fire, but we could do that as well. It's the same setup. We're not asked to solve the triangle, so we don't have to. We just needed the distance between tower 1 and the fire. I would guess that tower 1 then is the one with the helicopter. Okay, so make sure we answer the question that is asked. We have an instinct on these kinds of problems just to solve the triangle. Answer the question that's asked. We just need to find that distance. Okay? Questions on this one? This is a real thing, and that is actually how they mark where fires are. They do the bearings. They know the distance between the towers. So, like, this is really used. They have, like, the coordinates written on the windows around the whole fire tower. It's really cool. I follow a couple of fire spotters on TikTok. It's almost drop-off season, so they're getting ready to fly out to their cabins for the summer. All right. So our next one here is the surveyor one, just because I have no idea which order they printed it and if it's sideways or top down on your paper. So we've got a surveyor notes that the direction from point A to point B is south 63 west, and the direction to point C from point A, because wording is weird. Yes, dear. It's in the tray by the door, if you need them, just so that we didn't have to try and like speed rush and write paragraphs. I printed them out. So the distance, direction to point C from point A is south 38 west. And I have a distance from A to B. So both of these coordinates are pointing from point A. And they're both headed south. So we know A is kind of top-ish. So I'm going to put A near the top. I'm going to call this A. What's that? I said, what's that? Great. Then let's just like chill, or I'll have to separate you two whisperies. All right, so we're finding our directions here. We're using our little coordinate points. So from A to B is south 63 west. So we're going to go 63 degrees to the west. And that takes us to point B. That's 63 degrees there. And then from point A to point C, they just put it in the weird order. So this says to point C from point A is south 38 west. So this is 38. so good at drawing connecting lines, y'all. There we go. So this is point C. We know the distance from A to B is 239 yards. And from B to C is 374 yards. We are asked to find this distance. Where can we start? Or what should we start with? Find the what? Say it again. I can hear you. Angle A. Let's figure out what alpha is. Because I know that that left leg is 63 degrees away and the righter of the legs is 38 degrees away. So what is the measurement of the angle between them? It's the difference, right? So angle alpha is going to be 63 minus 38. It's the difference between. So what is the measurement of angle alpha? Mm-hmm. 25. So all this hot mess told us that this angle, bless you, is 25. From there, what can we get? If I know alpha and side A, where can we go from there? Yeah, I know side C. So we can find angle C. We're going to use our law of sines. We're setting up our ratio. We're going to do this guy, A over sine of alpha equals B over sine of beta, that kind of guy. But since we're looking for our angle this time, we flip it on its head. So we're going to wind up with our sine of 25 over our side A, which is 374. We know that's going to have the same ratio as the sine of angle C, which I'm going to switch to I'm going to do our Greek, gamma. And its side length was 239. We're looking for this angle because I need this angle to be able to find this distance. So we're going to have to kind of work our whole way around. So this one we are going to solve the triangle simply because I need all the pieces to get over here. So what are we going to do to get gamma by itself? We are going to have to inverse the sine. So we're going to wind up with arc sine or inverse sine of the whole thing. And I need to multiply it before I inverse sine it. Multiply by my denominator. So we're going to do the inverse sine of 239 sine of 25 over 374. That's a lot of stuff to type. I'm going to show you a way to do it where we don't have to like be perfect in our typing when it's Gigantor. Because there's a way to say, all right, take the thing I just did and put it inside a thing. So I'm going to just do my inside piece. So I'm going to do my fraction that has the 239 sine of 25 over 374. Easier to type. I can actually see the whole dang thing. I'm in radians again. I'm like, something's wrong. Okay. Like, it shouldn't be negative what I do wrong. There we go. All right. And then we want to inverse sine that. I don't want to retype it, though. So I'm going to go my inverse sine. And I'm going to hit the green button. And I'm going to hit the negative. And it says ANS. It says, all right, inverse sine my old answer. Whatever my previous answer was. So it lets us look at it or type it in smaller chunks. You can do it all in one big go. Totally fine. But that makes it off the screen a lot of times, and it's really hard to double check your typing. So we should get that our angle gamma is 15.668. So that equals gamma. So our gamma is 15.668. Which means my triangle is way out of scale, but that's okay. Because I have this as definitely an obtuse angle. When it's really 15 degrees. So I bet B is going to be kind of big. B is going to be bigger. That's okay, though. Our pictures aren't to scale. They're just to give us an idea of what's happening. That's why we're never busting out protractors. Like, that's not a thing. We're not doing that. No compasses, no protractors. So now I know alpha. I know gamma. How can we find beta? Triangle sum. My three interior angles are going to add up to 180. So alpha plus beta plus gamma equals 180. So I can find beta. And I'm writing big today, so it's running out of space. So what is the measurement of beta? Yeah, 139.312. So this guy, doesn't it look like 139 degrees? It's okay, we're getting it there. That lets us set up our final ratio to be able to get that dang distance they asked us for from A to C. And we can use any of the other ratios we have. It does not matter. They're all the same ratio. I'm going to use my alpha one because those are things we were given and they're less gross to type. But we want to get that distance, which is our side B, over our sine of 139.312. And we know it has the same ratio. Okay, I'm going to have to go to the right. There we go. As our alpha system, our 374 over sine of 25. Side over angle. They have the same ratio. So now we're getting ready to type this in the calculator. Multiply both sides by the sine of 139.312. Type the whole gosh darn thing in the calculator, and we can find this distance. What do we get as that distance when you type it? Oh, for the angle? Mm-hmm. It's entirely possible. I may have written it down wrong. pen. Here we go. I wrote it down as 312, but I probably did it in my head. I don't remember. I trust you. All right. It's not going to be a massive difference as far as the distance goes anyway. What do we get for that distance? 576.76? 706. 706 what? Yards. Yay for Americans. Who needs meters and yards? You okay, Joanna? Okay. Yes, you. You okay? Okay. You just looked shooketh for a second there. I was just making sure it wasn't me going, you going, what the heck just happened? Okay. So honestly, I think the most important part of your setup is giving yourself a sketch. Also allowing yourself the grace for it to be entirely wrong on your angles. It's okay. We're still just looking at those ratios. Yes,
For these sketches, should it all be drawn in the triangle, should it all be drawn in that manner?
you should have a triangle. It doesn't really matter what shape it is. It doesn't have to be an obtuse triangle. Like the one in my notebook, I drew entirely different. Like I have 2 acute triangles that I drew in my notebook. I have no idea why I did it this way. Oh, because I ran out of space on the C. I couldn't get it far enough to make it acute. So it doesn't really matter how you draw your shape as long as we're labeling things correctly. I am never going to measure your angles, and I don't want you to measure your angles. If you own a protractor, just like pitch it to the side. We're not using them. Okay, so we're just kind of getting the vibe. As long as you label your points and label your sides, I don't care what shape it is. I mean, I want it to be a triangle, but other than that, I don't care what kind of triangle. And we'll make sure I draw one that's not an obtuse triangle on the next one. Boop. Oh, shoot, except this one has to be an obtuse triangle. Sorry. Yeah. Let's do it. All right, so we've got a loading ramp that's 10 feet long. Makes an angle of 18 degrees with the ground. That's the horizontal, because they're extra. And they're going to buy a new ramp. They want to lessen that curve. They want to lower the ramp so it's less work to go up it. So it's got 12 degrees. So I'm going to draw us a picture. So we're getting up to our loading dock. And our original ramp, oops. Makes an angle of 18 degrees. And our current ramp is 10 feet long. We're looking at a wall of a building here, so we know that side's 90. Because we're going up to a loading dock. Then we're going to get a new ramp that is going to be longer because we want this angle to be sharper. So we're going to buy a new ramp that gets us down to 12 degrees. It's a narrower angle. And we want to figure out what this distance is. So I'm going to label this guy our height. Do we need to know the height of our dock? No, but we could find it if we wanted to. What do we need to know to be able to find this distance? So I'm just going to name this B. And this one's going to be C, and this one's going to be A. What do we need to know? I just labeled things so we could talk about this. In order to find distance D. Angle B. I need to know this so I can use my law of sine stuff. Yeah, and we're going to need to know, do we need to know angle A?
No.
Nah,
No.
I don't really care. What is angle B going to be? 162. Because this is a supplementary pair of angles. So 180 minus 18. So angle CBA, if we want to label it like that, you absolutely can. Tells you it's CBA. Is 162. So what can we do to set this up and figure out that distance? Do we know angle A? Do we know side A? Do we know angle C? Do we know side C? So do we need, well, do we? Because we know this one, it's 10. So do we need to know anything about A? No. Side C is the one that's across from my angle. That is the wrong pen. So side C is the length of this old ramp here, 10. So I'm going to set this up as my 10 over sine of angle C, which was 12. And it's going to have the same ratio as angle B to side B, which I've labeled as D because I'm making life difficult. Our distance that we're looking for here over the sine of that angle, 162. Solve this around. How long is the new ramp? Say it again. 14.863 feet. So the translation of the words into the picture is honestly, I think, the hardest part. So take your time when getting yourself a sketch. Make sure it kind of makes sense. Okay, we're not fitting the last one in clearly because we have 2 minutes to the bell. Oop. Yep. That one. If you could please put the scissors and glue sticks back in the boxes, that'd be great, because I'm going to hide them back from my algebra 2 kids because they make confetti.
I'm not going to be here tomorrow.
Okay, I'll get the video posted as quickly as I can.